Let's take a look at extreme value today. We've talked a little bit about maximums and minimums, and we want to clarify a little bit of the definitions here. So, relative and absolute extrema can be confusing, but let's see if we can make it a little bit simpler. So, relative extrema, this is where the function's changing from increasing to decreasing, or vice versa. So this is where you're getting that, and we did the first derivative test, and we're getting a maximum or minimum, a hill or a valley in the graph. Now, how is that different? Well, when we look at absolute extrema, this is the highest point or the lowest point on a function altogether. So you could have multiple relative maximums, but you can only have one absolute maximum. So this is the highest or the lowest point on a function. So again, you can have multiple relative maximums, relative minimums, but you can only have one absolute maximum, one absolute minimum. So looking at the graph of f of x, first of all here, let's identify the relative extrema. So we would say this is the relative maximum. And the relative maximum, we just have a hill right here, and that's at negative 1, 3. We can have a relative minimum, and it looks like I have two of those, right? I have one here at negative 3, 0, and I have another one here at positive 2, negative 6. So at negative 3, 0, and 2, negative 6. But what is the absolute extrema? Well, this one gets a little bit confusing because um, those values keep going up and up, right? So if we're looking for the absolute max, there is none because we keep going up and up and up. But absolute minimum, we definitely have one right there. And that is at the positive 2, positive 2, negative 6. Okay. Look at the last question. On the domain, did the absolute extrema occur at the function's relative extrema? Yes. Okay, on the graph of f of x, the absolute minimum happened at one of the relative minimums, but the absolute max did not. So let's just say that it could. The absolute extrema could be located at the relative extrema. Okay, let's look at the graph of G then, and we'll ask the same questions. So we're looking for the relative extrema on the graph of G. So let's do a relative max. And that's going to happen at this hill right here at negative 1, 4. Okay, and then our relative minimum happens here. That's at negative 3, negative 4. Then we have another valley right here at 3, 2. And now looking for the absolute maximum, the highest point on the graph altogether is going to be at this point here, and that's at 6, 5. And the absolute min, that's going to happen here at negative 3, negative 4. So I want you to see that the absolute max or min can actually happen at an endpoint. Okay, it doesn't have to happen at the same place as the relative extrema. It can, but it doesn't have to. Okay, let's keep looking then. Look at these two graphs here of f of x. So on the interval from -2 here to 3, so I'm going to just put a dot there, here to here. We're only looking at this section in between. Only looking at that section. What are the absolute extrema? Well, on that section, there's an absolute max at this hill here, -1, 3. And there's an absolute min at the valley here, -2, -6. Then it says, okay, now change the interval. So let's look at a different interval. We're going from -4, which is here, to 1, which is here. So if we're only looking at the section, and let me kind of cover some parts up so it'll make it a little bit clearer. If you've seen any of my other videos, you know my Sonic gift cards like my standby. And let me use just like a sticky note to mark off the other section here, right? So we're only looking at that section between those two red dots. Where is your absolute maximum? Looks like it's at this endpoint here. So absolute max at, looks like -4, +4. Okay. And my absolute min looks to be at the other endpoint at 1, -3. Okay, so if we change the intervals, we have to look at the endpoints differently because our maximum and minimums are going to look differently on those intervals. Okay, and then let's go ahead and do g of x over here. On the interval from -4 to 5, so let's mark those points, -4 to +5. Okay, if you want to use some things to kind of block out the view so you only see the portion of the graph that you need to see, I think that's good practice. So on this one, I think it's interesting to know that we have two maximums. Do you see them? You see how these 2 points are at the same height? So they're both considered an absolute max because their heights are exactly the same. And then my absolute minimum happens here, which would be at -3, -4. All right. Now, my next one says on the interval -2 to 6. So we're going from -2 to +6 now. So moving over my section to look at, here we go. My absolute maximum happens at that endpoint now because it's a little bit higher. So that happens at 6, 5. And my absolute minimum happens at that left endpoint. And that happens at -2, 0, looks like. All right, so now this good question. It says, when the domain is restricted, like each of these examples, when it was restricted on a closed interval, what 3 places could the absolute extrema exist? So it could exist where the derivative equals 0. So that's where you're getting that high or low, right? It could exist where the derivative is undefined. Because remember, where we have those sharp turns, right? We're not going to get a derivative. And the last place that it could exist would be at the endpoints. So you've got some places to look when you're trying to make the distinction between the absolute extrema, absolute maximum, and the relative max and min. That's very, very important. So let's get the extreme value theorem down. It basically says if the function is continuous on a closed interval, so notice those brackets there, then there is at least one absolute max and one absolute min on the closed interval. Now remember, back to our one that didn't have an absolute max or min. It was this graph, but it wasn't restricted domain. Okay, remember it was the whole domain, and we didn't have an absolute max because it wasn't on a closed interval. Okay, the domain was from negative infinity to positive infinity. When we closed the domain, then it forced it to have an absolute max or min. And that's the important part of the extreme value theorem. Okay, so let's look at it from an equation perspective. So we're going to look at this cubic function here. We're going to try to see if we can determine any increasing and decreasing maximums. Now this is going to be a review for us because we have done this already with the first derivative test. Let's begin by finding the first derivative. That would be negative 3x squared minus 12x minus 9. Now to find out where it's increasing or decreasing, we set that equal to 0. I'm going to go ahead and factor out a negative 3, make it a little easier for us to factor. And so I get my critical points. Remember that terminology. Critical points are where the derivative either equals 0 or is undefined. Then I'm going to make my number line. I'm going to be sure and label it because AP likes it to be labeled. And I'm going to put these values on there. Then I'm going to test my first derivative. I'm going to test x equals negative 4. And so I get a negative. Negative 4 plus 1 would also be a negative. And negative 4 plus 3 would also be a negative. Negative times a negative times a negative is a negative. Okay, next I'm going to test x equals negative 2. I get a negative. Negative 2 plus 1 is a negative. Negative 2 plus 3 is a positive. So I get a positive here. And then finally, I'm going to test x equals 0. And I get a negative, a positive, and a positive. So this is a negative. Okay, so remember what that means. When the derivative equals a negative number, we are decreasing. So we'll kind of summarize our results here. F of x is increasing on the interval negative 3 to negative 1. Notice the parentheses, not brackets. And decreasing on the interval negative infinity to negative 3 and negative 1 to positive infinity. Again, notice the parentheses, not brackets. Now, based on that, where do I have a maximum? So f of x has a max at x equals negative 1 because f prime changes from positive to negative. So notice all the abbreviations I'm using to make that a little bit easier, but each part is very important, so make sure you've got all that phrasing in there. And f of x has a minimum at x equals negative 3 because f prime changes from negative to positive. All of that is necessary for that justification. Very, very important there. Okay, let's finish up with this graph here. We're being given a function on this closed interval. So where would the absolute maximum be here on the interval from -4 to -4 to -1 here? So we're going to have to close our picture in. We're just looking at this section of the graph here, on the left of my Sonic gift card. So we have actually two of them, right? Because we have an absolute min here. They're the same value. So we have one at -4. Let's see, 1, 2, 3, 4, 5, 6, and -1, 6. Whereas the minimum on that interval, it's our lowest value. It's at -3, 2. Okay, now if I look at the whole graph, where is my absolute minimum? I'm sorry, absolute maximum. They're at the same place, right? Those are still the highest points on the graph. But now my absolute minimum changes to this value, which is at 1, -14. So I hope this helps, just kind of clarifying that terminology between relative minimum and maximum, absolute minimum and maximum. And thanks for watching. Bye.